In the last video, we understood the basics of RabbitMQ and the AMQP connector in Mule. Having that as a base, we will now try to create a reliability framework using RabbitMQ. Now let's understand the design of this framework. So we have a RabbitMQ, then the Mule server where we'll host the API implementations. RabbitMQ will basically have the origin queue, which is orders queue in this case, from where the messages will come and will be processed by a Mule application. Then we have the dead letter queue, where the messages will be pushed for retry, or in case of any transient errors, the message would land into this queue. And the last queue is the poison queue. So as the name suggests, this would be poison messages which cannot be processed unless and until there is a manual intervention. We can also call it as an error queue. Then we have the orders API, which is an implementation that will do some processing, business processing. Then we have a utility API, which is dlq-utility-api, which is basically used to handle transient errors, and all those messages which are present in the dead letter queue will be processed by the dlq-utility-api. Then we have the error utility API, which listens to the poison queue to handle the messages which are errored out due to some permanent error, and a manual intervention is quite necessary in that case. Then we have two databases. One is the dehydration DB and the other is error DB. So dehydration DB will store all the data which will have some sort of an expiry, which means that those messages can be retried after a certain interval of time because they had some transient errors. The transient errors could be errors which might occur due to connectivity, and after some period of time it gets resolved automatically, so no manual intervention required as such. The name dehydration DB comes from Oracle SOA, wherein they have the concept of dehydration DB. So the idea is that this dehydration DB will provide a place for messages to stay for a while and then be re-triggered again. So it gives you the ability to pause a particular processing. So we'll see that while we work on the demo of this framework, but just to give you an idea what is a dehydration DB. Then we have the error DB. So error DB, it's quite obvious, it will store all the error messages which do require some manual intervention. Now let's try to understand the actual flow. So as usual, we know that all the queues in RabbitMQ are bound to default exchange, even if they are not explicitly bound to any exchange. So all the queues are bound to this default exchange, irrespective of the fact if they are even bound to some other exchange, but they'll have at least one exchange which is a default exchange. Then when a message is placed into the orders queue, it goes to the orders API. It's basically pushed to the orders API by RabbitMQ. Then suppose in the orders API there occurs a transient error, which could be a connectivity error in this case. So it's not a wise idea to push the message to the error DB, right, or to the poison queue. So what basically this API will do is it will reject the message, basically send a negative acknowledgement using the reject AMQP connector. So once the message is rejected, the queue will move the message to the dead letter exchange based on what dead letter exchange has been configured. We saw this in the previous video, right? We can configure dead letter exchange along with the routing key, and then the exchange will automatically move it to the other queue. So in this case it is dead letter queue and the routing key is dlq. So the API rejected the message. Now the queue took the message from the queue itself and pushed it to dlx, which is dead letter exchange, and using the routing queue dlq, and it lands into the dead letter queue. Once it is in a dead letter queue, this queue will push the message to dlq-utility-api. So the idea of this dlq-utility-api is it will just take the whole message along with the attributes and the payload and it will add a few parameters to it and push it into dehydration db. So one such parameter is the x dlq retry count. So this gives us an idea that how many times was this message retried. So now the count would be 1. We'll increment the count and push it to the dehydration db. Along with that, it will have an expiry timestamp which will represent that when should the message be next retried. So if you see, it pushes the message to the dehydration db, and then there is a scheduler in this particular API which polls the database based on the expiry timestamp. Means it will compare from the current timestamp. If the expiry has exceeded the current timestamp, in that case we will poll the records from the DB and automatically push the payload to the origin queue from where it all started. So if any connectivity error occurs, the message comes into the dehydration DB, stays there for some amount of time until it expires. Once the time expires, it will be retried and pushed to the same queue. So it goes to the same queue and then it will be retried over here. Now in case we'll configure some retry limit, and that can be configured at the orders API. We can configure here itself, but I just wanted the consumer application to have the ability to reject. So we can configure any amount of retries. This dlq utility API will just help us to push the message to dehydration DB by adding dlq retry count and expiry timestamp. So the application should have the onus on itself how many times it has to retry. So the retry count will be configured here, and in case if the retries are exceeded, for example the retry count was 3 or 4, whatever it is, so it will reject it for like 4 times, and when the 5th times it comes, it will just move it to the poison queue, which means that now the error is not transient anymore. Although it is connectivity, but it's not transient. It's like a long outage and it needs some manual intervention. Although the message can be retried, message is not poisonous in this case, but the problem which is occurring is there's a long outage, right? Although it can be retried, but we are just moving it to poison queue. So once the retries are exhausted, we move to this queue, and from this queue it's being pushed to the error utility API, which will then push the message to error DB. Now in case if there is another error which is not transient in nature, for example it could be a data view expression failing because the publisher sent some wrong message, or the message does not honors a schema which we have implemented, right? In such cases it's wise idea to move it to the poison queue. So even in that case the APIs will move the message to the poison queue. So this two tasks of deciding if it is retry exhausted or whether to move it to the poison queue has to be done by the API which will be developed. So this API are not part of the framework, but this is one such API which will leverage the framework. The APIs that are part of this framework is dlq utility API and the error utility API. Now we have another ability in this error utility API, which is that even this API will poll for message from the error DB, and the mechanism for polling will be that the retry flag should be Y. Now you might be wondering, why should poison messages be retried, right? But if you observe in this case of retries exhausted, there could be a long outage, right? And the message could be good, but due to long outage the retries were exhausted. So it still is a case wherein we would want to retry the message, right? So for that ability I have given this option of retry flag equals to Y. If it is Y, the message can be retried and it will again pushed back to the origin queue. So that's the overall idea. Now let's move on to the DB design. So the first table that we have is the dehydration DB. Now let's understand what all column does it have. So we have ID as the primary key for this table, and it's a numeric value which would be of length 6. We can have this any length we want depending upon the volume that we might expect, but Yeah, do have correlation ID, and the reason why I haven't kept it as unique primary key is that there might be occurrences when, like, since this is a framework, right? So there is a high possibility that it will be used by multiple API implementations, and in that case, there could be some chances that the correlation ID might get duplicated. There might be. So instead, I have chosen ID to be unique, and this ID would be created by a database sequence, which is again thread safe, so we need not worry about it. So the ID, in case here, it is number and it's the primary key. System name. So the system name would be the name of the system which is pushing this message to the database, which will be dlq-utility-api in this case. Now it won't be the name of the application where the error occurred or which wants to pause the message. The reason behind this is that in case if you reject the message is handled by the queue. While rejecting, we cannot add any metadata to the queue, due to which we cannot add the rejecting application's name. So this system name will only hold the value of the implementation or the application which is pushing the data to the database, which is dlq utility API in this case. Created timestamp, it's quite obvious, the duration, the time when it was created, and it's of type timestamp. Expiry timestamp. So this expiry timestamp, like we discussed in the previous slide, it will dictate how long should the message stay there in the DB before it is retried. So this expiry timestamp will increase exponentially. For example, there occurs a connectivity error in the first attempt. The expiry timestamp would be, for example, 4 to the power 1, which is 4 seconds. I mean, from the created timestamp, it will add 4 seconds to the created timestamp, which means that after 4 seconds, it will be retried. Then if it comes for the second time, it will be 4 to the power 2, which is 16. So it will add 16 seconds to the created timestamp, and then after 16 seconds it will be retried. So that's the logic. So that is what we have the expiry timestamp for. Exchange is the original exchange from where the message was pushed to the queue. Routing key is the routing key which was used by the exchange to push to any particular queue. So in case if it was pushed directly to the queue, the routing key would be the queue name. These things we have already seen in the first video. Like, now payload. So I have chosen the payload to be a blob because I don't know what type of payload and what length would be there of the payload, because it's a framework, right? And it should be generic. It can have any length. We don't know what payload can be, so we kept it as blob. We need MIME type. The reason we need MIME type is when we recreate the message from DB, like when we store the message, it will be in the form of a blob, right? Which is that it will be a serialized object, and we need to deserialize it when bringing it back. So we need to know the MIME type, right? We'll use the functions like read and write. So if we read it, we should also know what is the MIME type of that payload. So for that we are using this MIME type. Headers, as we know that we are adding a header called as xdlq retry count. So this API will just keep on incrementing the retry counts, and that will be stored in headers. And properties will have all the properties of that particular message. So headers and properties are part of the attributes, and I've used varchar2 4000 because I know that headers and properties would be of specific limit. It won't exceed that limit, so I've kept it as varchar. So that's the idea of a dehydration DB. Now let's understand the another DB, which is error DB. Now the error DB is quite similar to the dehydration DB, with the only thing like it has some additional properties like retry flag, cause, description, and I guess and type. Yeah, so these are the additional things that we have, and we do not have any expiry over here as opposed to the dehydration DB, because this DB should not have the ability to retry the messages automatically after some time, because this messages do require some manual intervention. If in case of error which is like schema errors or any permanent errors, it does require manual intervention, like maybe someone needs to correct the message and retry it again, or in case if it has exhausted all the retries from the dehydration db, even in that case someone has to manually go and change this retry flag for it to get retried. So now let's again see this table structure. So id again over here is primary key, and this is generated by the database sequence. Then correlation id, system name is the one application which pushes the message to this queue. So any message, any poisoned message, or which the message which fails will obviously be pushed by the source application. So in this case we will be able to retain the name. For example, orders API, it won't reject the message, now it has to manually push the message to another queue. So in that case, obviously in this case we will have the system name as the origin application where the error occurred, and not the error utility API. Now if we talk about type, so this type will basically be the error type. For example, if it is mule connectivity, mule security, or something of that sort, so it will have the namespace and identifier construct of the error. Description, the error dot description. Cause is the reason why the message fails, any a single 2 to 3 words, whatever you want to describe the error as. Create a timestamp, it's usual. Exchange, the exchange from which the message originated along with the routing key. Payload is again blob, mime type headers, and everything is similar. We just have this retry flag which is a single character. It will be y or n depending on if the message can be retried or not. So by default whenever we push the message we'll have it as n. Then if someone wants to retry it, then he has to change it to y so that the message gets retried. And once it's retried, it will change its state to I. I will indicate that the message has been retried. So that's the overall idea of the database. Now let's move on to the actual implementation and let's see everything in action. In the interest of time, I have already created all the required implementations, and what we will do is like we'll go through the detailed implementation of what exactly has been done over here. So the idea is to use all of these three APIs at a time, and to make that happen I don't want to like start one API then start other API, start and stop. So instead I want all of the three APIs to run simultaneously so that we can see the orchestration among all the APIs and the desired output. So I have bound all these three APIs to one domain, which is the reliability domain, so that all of them get deployed to the single runtime, right? So we have all of them linked to the reliability domain, and the reliability domain has just two configuration. One is the AMQP and the other one is the DB. Like we saw in the slide, right, we only have two systems which Mule integrates, AM RabbitMQ and the database. Now if we see, we have the dlq utility API, error utility API, and the orders API. So let's first start with the dlq utility API. In this we'll try to understand first the dlq utility API.xml, which reads the message from the queue. So here's the queue configuration. We are giving the queue name as dead letter queue. Fallback queue definition is not there, which means the queue has to be there. In case if it's not, then it throws error. Acknowledgement is manual, will manually acknowledge, so we want the control in our hands. So that's the basic configuration. All other things are set to default. So now let's just move ahead. Here we are setting the current timestamp, like we want to push the timestamp when this process started, so I've just used now as date time in current timestamp, or we can also specify this directly in the transform. Then we have a transform which will basically enrich the message that has to be pushed to the database. So let's see what we are doing over here. Let's try to analyze this transform. So first one is the system name, like we saw in the previous slides, right, where the system name identifies the name of the system. But since in case of dead letter utility API, the message will be rejected from the source. So in that case, the source application cannot enrich the message, right? So basically we'll only have the app name, which is dlq-utility-api in this case. So system name will be always with dlq-utility-api or any other API which directly pushes the data to the dehydration DB. So that will be the case, but it won't have the source application which rejected the message. Then we have the correlation ID. Now correlation ID, we are retrieving it from the attributes. So the attributes has properties. We can see everything is populated at the left, right? So this is the metadata that comes from the AMQP listener. So we are getting this from attributes, properties, and correlation ID. And if it is not there, in case if it is not populated in the properties, we'll generate our own. But it's mandatory that while pushing the message to RabbitMQ, we populate this value so that we have a distributed traceability among all the other APIs. Alright, so that is about correlation ID. Then we have payload. So for payload, what we are doing is we are using this write function. So we are getting the payload. Now we don't know what the payload could be. It could be XML, JSON, CSV, or any media type, right? So we are using this particular format to identify the media type and the payload, and then we are using the write function. The reason we use write function is that we want to serialize the data so that it becomes into a string format. So it could be a JSON string, it could be an XML string. It's basically serialized now, which means that doing this will help us to write the data to some persistent storage, right? So that is why we serialize it. So once we are serializing it, we convert it to binary. So this helps us to push the data into the database, which has the payload as type blob, binary large object. So since it is blob, we are converting it to binary by specifying the class as byte array. So this is how we make a blob and push it to DB. Then we have the exchange. Now the exchange comes from headers, so attributes headers and xdeth. So we have the xdeth object in the headers. It's an array. Let me just show you. So if I go to this example, so this is a rejected message and I have just printed the attributes. So if we see, we have in headers we have something called as xdeth, which is an array of objects, right? So in this we are picking up the 0th element, which is this. It has only one, right? So we are picking the 0th element, and from there what we are doing is we are getting the exchange and stream from that. So if we go back and see exchange and the stream, so if you see the stream over here is order is exchange. So this is what we are trying to get, the original exchange, and this always remains the same, the structure. So that is why I have just hard coded as 0th element and then take the stream from that. So that is what we are doing over here. Now in this case I want you to ignore this queue completely because we do not have this column as queue. Instead we are using routing key. So the idea over here is that I do not want to publish the message to exchange at all. I just want to publish it to the queue, and the queue name will be routing key. Now you might be wondering, I should have used the name queue rather than routing key. That's fair enough, but when we publish the message using the publish connector, it doesn't ask for queue name. Instead it asks for the routing key. For example, if you see this publish, and here we have only routing key, which is not the queue name, right? So when we only want, when it's written as routing key, I thought of adding as a routing key, and in routing key if you specify just the queue name in an array, it will publish directly to the queue. But make sure that the exchange is left as blank defines the default exchange. So it's a default exchange and the routing key is queue name, so it will directly publish to the queue. Now the question comes to the mind is that why to deliver the message directly to the queue rather than the exchange? And that's a fair question, but think of it from a perspective of a framework, that it will be used by any application, right? If we deploy it as a framework to be utilized, there will be multiple applications using it. So in case if we have some exchanges which are fan out exchange, so in that case we do not have any routing key, right? They'll be published to all different queues which are linked to that, bound to that particular exchange. And suppose there are three queues bound to one exchange, and all of these three queues are sending message to individual different applications, and out of these three only one application is experiencing connectivity errors or some transient errors. So it's not a wise idea to publish the message to the exchange directly, right? Because it will fan out the same message again to all the three APIs. And if these APIs do not like duplicate message, like if they do not check for duplicate message, in that case we will have a problem, right? So it makes sense to publish to only the queue from where the message came into the dead letter. So that is why I'm using this routing key, and in this routing key I'm having queue as the name. So that's the idea behind routing key, and just ignore this queue because we do not have any queue column in our DB. Then we have the expiry timestamp. So expiry timestamp is current timestamp plus the backoff period. Now this backoff period is exponential, and how do I calculate this? It's using this formula. So what I'm doing is, whatever value I'm getting with 4 to the power, I'm just multiplying it with 10. So I'm raising 4 to the power of the retry count. So initially when the message first gets rejected, it won't have any headers called as the retry count, so it will be 0. So first it will be 4 to the power 0, which means 1, so 10. So it will add a delay of 10 seconds. In the second turn it will be 4 to the power 1, so it will become 4 and it becomes 40. Then the next time it becomes 4 to the power 2, which becomes 16, then 160 seconds. So PT is used to represent period, so I'll use this value back off, which will get evaluated like 40 seconds. So PT 40 seconds will be added to the current timestamp. So that's the idea. So it first increases by 40 seconds, then increases by 160 seconds, depending on the value that we get from the dlq retry count. Alright, then we have the created timestamp. That's quite obvious. MIME type, so we are getting the MIME type from the attributes, properties, content type, and default is set to blank, and we won't get it. So it's quite necessary that we send the MIME type. In case if we send the messages manually from the exchange, we need to pass all this value, and if it is through some application, in that case it's automatically sent. So that's the reason I'm adding default, if in case if someone sends and it's missing out, so just to avoid any errors. But these properties are quite necessary to have. Then same goes for properties. We do need to write it, like we are making it as a varchar in the DB, right? So if we just send it the properties, that would be some JSON object, and it won't be able to convert into varchar. So we are using write function. So write function makes it serializable, and the serializable, as we all know, can be persisted to any storage system, right? So that's what we are doing. Then coming to the headers, now there's some logic to this headers, and let's try to understand what we are really trying to do over here. So headers is again part of attributes. If you see headers in attributes, so we have properties, envelope, and then headers. So we are getting headers. We are running a map object. So map object gives us 3 different parameters, and value, key, and index, and we are trying to call some function and pass the value. So this basically is a recursive function which keeps calling itself until and unless it encounters an object. So if it is a type of array, it calls it again. If it is an object, it will just try to get the stream value from it. So let's try to better understand with an example. So here is an example. I have this header, and this particular headers is until here, line number 39, right? And it has this x death array, and x death first death reason, first death q. So that's the structure, right? And I have pasted the script over here, and if you see, what we are getting is we are getting the death exchange, the death reason, and the first death queue. So this is what we wanted. So in case if it encounters the array over here, it will again call the same function until it gets an object. So it got an object, and inside the object it will search for object dot stream. So when it goes to this queue, it will get the stream, and similarly it will try to just output the value. For example, here first death reason, it got uh, first death exchange, so it got orders x. First death reason, it got rejected, and the first death queue, it got orders q. And the next death, it got nothing because it was an array, and inside the array we didn't have a direct object stream. So reason is an object, but it internally has stream, right? So this object won't fit in, so the death one is null, whereas this one fits in properly because object dot stream gives us the values. So we are just interested in these three values, and we don't want this complete thing. So that is why I've added this function to just get down this, boil down the whole headers to this 4 value. All these values are not much useful to me. And then I'm removing this x death. Let's see that. So yeah, so if we see this, I am removing x dlq retry count. If it is present with a null value, we'll just remove it, and x death also will be removed. So these two headers will be removed, and instead we'll have an updated value for dlq retry count. So how are we doing that? If you see over here, we're doing attributes dot headers and x dlq retry count. So we are getting the value from headers, and then we are adding 1 to it. We are incrementing it by 1. So that is how we are incrementing these values, and then we are just giving the MIME type, which is JSON. Like, we know that the value will be of the form of JSON, right? So in the end, what we will get is a value something like this. X death will be removed, and it will have an extra field which is x dlq retry count, which should be the incremented value. If it was not set, it will be 1. If it was set, then the value plus 1. So that's the idea about headers. So headers has a key value, main important value, which is dlq retry count, which dictates how many times the message should be retried by any other APIs, right? So that's about this small but quite important transformations, because this is doing the whole job over here. Now then, we are pushing the message to the database. So we have the insert query, wherein we are just pushing ID, system name, and all the values, and we have already set the values in the transform. One important thing to notice is that I've used the next val of the dehydration DB sequence. So I created a sequence in database rather than pushing the unique key from here, because correlation ID is not necessary. It can be unique, and this generating a unique value from here might involve doing a select query and then getting the latest count of the ID and then changing it. But that might get affected because of the race condition, because suppose if you have multiple messages being pushed from the queue and your flow has max concurrency of 2 or 4, in that case all get the same value, but while writing any one of them can push the value, right? So they get the value 10 from the ID, maximum ID is 10, then both of them increment it by 1, and one of them moves to the DB first and the second one wasn't able to move first. So the second one, when it pushes the value 11, it gets a primary key violation. So to get rid of that overhead, I have decided to go with the sequence. Now the sequence at the database level is thread safe, so I need not worry about anything. So I'll just use next val, and it will give me a unique value every single time. So that's the idea. Then once everything gets successful, we are acknowledging it. Now in worst case, if there goes something wrong over here, which usually might not, but connections could be unstable, right? Transform is fine, everything is a track, so there's very low chance that anything might fail over here. But what might fail is, oh, here the database call. Now queue calls might not fail, because if it fails then the message will not come in the first place. And in case if it happens, like the message comes and then something fails and acknowledge, and it might be a possibility, so we do need to handle error in this case. So in case if any error occurs, the only resort that we have is to push it to the error queue, because this queue won't have any dead letter queue assigned to it, right? So it's final, like we cannot retry because this queue itself has the job to retry. And if it fails, it's it's a high priority thing that needs to be considered, so it's better to raise an alert and just push it to the error queue or the poison queue. So let's see what we are doing over here. So in case if we get any errors, we'll push the app ID, which basically is the app name. Now the table structure is different for the error queue, so we are sending some values that the error utility API will use. So we'll slowly go to that, but let's understand what we are sending. So we are sending the app ID, which is the app name. So the error queue will always get the exact app name on which the error has occurred. Like even the orders API will also have to implement some similar structure, right? So we are giving the app name, which will be dlq-utility-api in this case. Then coming to message, again we are storing the backup of this message. So in case if we are inserting, right, so insert will change the payload. So in that case, suppose if it fails after inserting at ACK or something goes wrong, we might lose the actual object or the payload that we received. So that is why I've created a backup. So it's created over here. If I go over here and I show you the variables, so I have ACK ID, backup, and attributes, because this has the ability to change the mule event. If we see the payload, it will give the rows affected, right, or the number of insertions. It will give some sort of payload, so we'll lose the payload. So I just created a backup variable, and which will have the payload. So here's the payload. So that's what I'm doing. So I'm using the write function again. The message would be a blob type, so changing it into binary will be handled by the error utility API. My uh, I would need to send this just a serialized data, and everything will be handled by the error utility API. The cause over here is error, so I'll talk about this cause later on, but right now it's just an error. Now the description is errors.description. So this let me just talk about this cause. So this cause will be like in case if any other, for example, the orders API has retried the message for 3 times, right? So it has reached the limit, it has hit the limit. So in that case, the cause will change to retries exhausted. So there will be two causes. One is either error and the other one is retries exhausted. Description, it's quite obvious, we'll send whatever the error description that we have. Then in type, like I said, we need to use namespace and identifier construct. So that is what we are doing, error.error type. So that will be an object, and to avoid any errors I'm just giving a default object. So error.error type will get an object. From that we'll get the namespace, and we'll concatenate with colon. Then we'll add the identifier. So it will be something like this. Namespace will be mule colon connectivity. So that is what I'm trying to create using this type. Then attributes will have all the attributes. Now I'm not serializing this, I'm just sending as is, which means it will be a JSON object, because it has to be used by the error utility API. So we'll see that in error utility API. So I hope you have got an understanding of how this dlq utility API works. So it will just enrich the message, add the dlq retry count, and push the data to db. In case if any error occurs, it will then just publish the message to the error queue or the poison queue. So having understood that, now let's move to the another flow XML, which is the expired messages. So one is to push the data to the database, and the other one is to read expired messages from the database. So let's just see what's there in this. So we have a scheduler which we can configure as per our requirement, set the frequency and start delay. Then we have the database select call, and this select call, it's the expiry timestamp. Like we saw in the database structure, it's like the expiry timestamp has uh, the future date, which is like which will be current timestamp plus the backoff period. So if the expiry timestamp is less than the current timestamp, which means the job is expired, we'll get all those records, right? So once we get those records, we'll do some processing. We just want to push the message to the original queue, right? So that is what we are trying to do. So if we go to this choice route, we are just checking if it is not an empty payload, we'll work on it. So if we get some records, right, so we'll need to process those. So we have a for each loop, and in this particular for each loop I have used a dynamic evaluate. Now the reason why I'm using the dynamic evaluate is I want to reconstruct the original payload, right? The payload that I'll have will be of blob, right? So I just need to reconstruct the payload. So what I'll do is I'm using this sort of a syntax. Now let me just explain you what's going on over here. So let me just copy this piece of code into Notepad so that we can get a better understanding of what's happening. Alright, so if I just paste it over here. Okay, it didn't come up. Okay, right, let me paste it in another tab. Alright, so what I'm trying to do is I'm trying to just create a script which will be then evaluated by the dynamic evaluate. So output plus plus payload dot mime type, then split by semicolon, and then I'll pick up the 0th element. So if we see, this is the content type which I'll possibly push to the database. So the mime type that DB has will be application XML semicolon character set UTF equals to 8. So this will come from the RabbitMQ and the properties in the attributes properties, right? So that's the reason I'm using split by semicolon, and then I select the 0th element, which is application JSON. So this will become output space application JSON or application XML or whatever it is, depending on the MIME type that has been sent. Then I'm adding this 3 hyphens, so just separating the header part and the body part, and then I'm using the read function. Now using the read function I get payload dot payload. So we saw in the first flow, right, when we are pushing the message to the database, it has a column called as payload, which is a blob. So we get the payload from this, and then using payload dot mime type, which has been used here. So we use the payload dot mime type to read the payload. So we get the payload is read, and using this output it's converted to application JSON or application XML or whatever it is. So that's the idea, and we are just pushing it into a message variable. The value will be payload, which will get created by this particular evaluate script. So I hope you understood why did we use evaluate, because we do not know what is the MIME type of that particular payload. Since this is generic, it might get application JSON, application XML, and we want everything to be evaluated at runtime. So that's the reason we are using dynamic evaluate. Then I'm setting the properties. The properties are serialized. Now we need to deserialize when reading from DB. So payload.properties. Now I know that it's application JSON every time. So these things won't change. What will change is the payload. We do not know the MIME type of payload, but the attributes of the AMQP connector which emits, it will always be in JSON, so we can confidently hard code it as application JSON. That's not gonna change anytime. Again, for headers, same thing. We are just reading payload.headers, then the application JSON, and just rendering. So we don't need any dynamic evaluate over here. We just need the read function as is. All right. Then we are publishing the message to the original queue. So how are we doing that? So like I have explained before, right, we do not want to publish it to the exchange with the routing key because this is something generic, and there could be exchanges which might be fan out and can publish to all the queues, and if we use that mechanism, fanning out to the queues which process the message successfully doesn't make sense. So for the same reason, I am just keeping the exchange as blank, so it's the default exchange. And in case if we use default exchange, and if you want to pass the message to queue, the routing key is the queue name. So the routing key will be the queue name, and that is what you have seen in the first flow. So we are sending the queue name in array, so it directly publishes to the queue using the default exchange. So once the message is pushed back to the original queue, now it will have that xdlq retry count. So we are sending the message var.message. We are sending the AMQ property. So what all properties we have set, we are just sending it. So var.properties content type, encoding, priority, correlation ID, message ID. So everything we are sending, and then we are sending whatever headers we had. So basically this is what we are going to send. This is what we are going to send. This won't be there. Instead we'll have the xdlq retry count with whatever the count is. So it will be pushed back to the original queue. So if we are able to push it successfully to the original queue, we should delete the record, because there's no point of having that record, right? Since it's like a pause or some short period of time, the record should stay there. It should not stay there forever. So the ideal situation for that DB is it will always be empty when the jobs are all the jobs are processed or all the messages are processed. So it should not accumulate the data anytime. It should get rid of it. Messages should get expired. If we don't want to get rid of the data, then it should be pushed to the error DB, because it will have all the details of all the error records and it will stay there forever. So we are just deleting based on the ID that we got. So yeah, that's it about this particular flow. And we have the default route that if no records are found, it's fine. We don't I mean, if no records are found, we'll just do nothing, right? And over here I haven't done any error handling because I know the messages are safe. They won't go to unact state or anything. They are in the DB. So in case if anything goes wrong, like it is not able to publish or it is not able to this won't error out, that's for sure, because uh, like it doesn't have any business logic or anything that someone might send something wrong. So there's very low chances of this failing out. Publish can fail out because of connectivity errors, or the database delete can fail. So even if this fails, the message is still there safe in the database. So we do not need to worry about reliability or anything in this case. Just get the data and delete it. But you can add some error handling just to log something or raise some alerts. But for the sake of simplicity, I haven't done anything yet. So that's about the dlq utility API. Now let's move ahead and understand the error utility API. So even this API is similar, not same, but similar to dlq utility API. It's just that dlq utility API does some slightly different enrichment of the message and pushes to dehydration DB. Error utility also does some slight different enrichment and pushes it to the error DB. So let's see what are the key differences over here. So the differences will be in transform alone. So let's see that. So if we see, the system name previously was app.name, so every time it would be dlq manager API, whereas in this case it will be payload.app id, which the sending application needs to send in the payload as app ID. So that will be sent. If I show you, if we go back to the dlq API, if we see in case of error, it pushes to the error queue, right? So in this app ID, we have this as app name. The other important change is the cause. So in case if the payload has any cause, for example, if it gets rejected, if it gets retried multiple times from the orders API, so it has a limit of 3, right? And after 3, the application will add some cause to it. So it will add a cause like retry is exhausted or something, right? So we'll have that payload as cause, and if that cause is not present, we have default as poison, because the error queue is a sort of queue which has poison messages, like they cannot be retried without manual intervention. Then payload remains same as is. Now if we observe that even for attributes, properties and headers, we are getting those from the payload and not from the attributes that come from the message in the queue, right? And that's because the original message will have its set of attributes and properties, and when they come in to the application and it sends a message to error queue, that might get changed, right? That might get altered. So it's quite important that while sending, we send the original headers and properties in the payload. So that thing, all the applications need to do, they need to send everything in the attributes uh, object in the payload. So if we see the dlq-utility-api error, we see that in attributes we have taken a backup of attributes in variable attribute and we are sending the same. So this attribute will have original headers and the original properties. So that's what we are going to leverage in this case. So yeah, that's about properties and the headers. And uh, what else do we have different over here? Nothing. It's quite the same, right? Yeah. So alright, then we have the retry flag. So if the cause is retry exhausted, we can make it as y, that we can retry the message once more if we want. So that's the reason we are making it as y. And if it is some other reason, we'll just keep it as n, which means that it cannot be retried. And if it is y, it will be picked up by the scheduler in some time. So that's the only difference that we have over here. So now let's move on to the error DB. And the error DB is no different. It has all the values that we want to push, and we're just mapping everything with the keys that we made in this transform. Then we have the ACK. Once it's successfully done, we'll just acknowledge. And in worst case, if there is an error, we can't do much over here because this API was the last resort for all the errors. So in case if there is any error, we just log it, and maybe we can configure some critical alerts from the runtime manager or something of that sort, and that's the only thing we can do. That's the best we can do. And don't worry, the message will not be lost because we won't send any acknowledgement, right? If it fails somewhere before ACK, we won't be able to send acknowledgement, so the message will stay there in queue for unact state, and this alert will get triggered. So someone has to manually stop the API and then maybe try to start so that the message gets picked up. And again, if it fails, then just take the backup of message or move the message to some other queue and then check what was wrong. But ideally the chances of errors coming here would be very low, and that would be only connectivity errors, because this transform and everything will be decided as part of the contract. So that there's quite less probability of this thing failing, unless and until we change the whole connector itself. In that case, like the AMQP gets changed with some other message queue, right? So in that case, the headers and attributes that will get changed. So that won't that like that's a totally backward incompatible change. So those chances of errors are quite low. Only connectivity errors can occur. So that's about the error utility API flow from message queue. Now the second part to it is retrying the message when the flag is changed, right? So if you have the flag as y, the message is eligible for retry. So someone manually goes there and changes the end flag to y, he can, the message can be retried, or maybe I flag. So we discussed in the slides, right? If the message is changed to y, then once it is retried, the status gets changed to I, which represents that the message was retried previously. So we have a scheduler, same thing. We select the message. In this case, we do not have less than the current timestamp. Instead, we are checking for the retry flag, which is retry equals y. Then same thing, we have the choice root. Dynamic evaluate, I've explained this earlier. So it just reads the payload, uses the MIME type, and then creates the payload out of the blob. Then we have the properties, the headers, and as usual, we publish everything. Now, one important point to note in this error utility API was, just forgot to mention it, like we are removing this xdlq retry count. So if the message has exhausted all its retry, it will definitely have the xdlq retry count, which will be like maybe 1, 2, or 3. So the reason why I'm removing it over here is like sometime in the future the message goes to the DB and it has a status as Y, right? Since it has the status as Y, the message will have this dlq retry count as the maximum value, which could be 3 or 4 or whatever is set. So if it goes back with the same header, it won't it will, it's high likely that if it errors out, it again reaches the error queue. I mean, it to the dehydration anymore, because it has already exceeded. So it got one chance, and it again, if it failed in that chance, it will be back to this queue without any retries, right? So it's better to remove this, so that in case if the connectivity error is still not resolved, it will go to the dehydration DB and maybe start the 4 attempts altogether again. So that's a design choice that we need to make depending on what trade-offs can we bear and what we cannot bear. So that was a point that I wanted to mention. And then once we publish the message, we just want to update the flag to I, and that is what I am doing. So update error db, set retry flag as I based on the payload.id. So that is what I'm doing, and then if there is no records, nothing to do. So that's the overall flow for the error utility API. So I hope you have understood the dlq utility API and the error utility APIs. Then we have the orders API. So this order API is not part of the framework. These two are part of the framework. Now this is any new API that wants to leverage the framework, right? So let's see what I have done. So this API does not do anything. It just throws an error so that we can understand what's happening around. So when I read the message, I create a backup. I have a payload and the attributes, because if there is some error, I need to pass these attributes to the error utility API, right? So I have to add this. So I'm just taking a backup, because if there is some processing happening in this API further in flow reference or anything, there's a likelihood that this values might get changed. So I'm just taking backup of everything, right? Then I raise a connectivity error, my custom error, my company connectivity. And to handle this, I've created a global error handler. So you can also create a global error handler which will do the task of pushing the message either to the dlq or to the error utility API. So this logic has to be implemented in every single API implementation. So since this is something reusable, it makes sense to create a global error handler which can be directly copy pasted, or maybe you can create a jar out of it and just add it as a dependency. So in case if you're not sure how to do that, you can just refer my video on class loading isolation. In that I have demonstrated how we can you import a flow from a jar. So now let's understand the global error handler. So we have on error propagate and we have a choice route. So this choice route will basically check the headers if it has dlq retry count. So if the dlq retry count is less than 2, then we have made it eligible to be retried, so we'll basically reject the message. And when we reject the message, we don't need to send anything. The message from the queue itself will be pushed to some other queue based on the routing key. In this case, it will be moved to the dead letter queue. So we just log a warn message saying that the message is rejected with whatever is the retry count. And in case if it's something different, suppose it has exceeded the retry count, it goes to the default route, and in this default route we have a cause. I think the machine has froze. Okay, yeah, so the retry is exhausted is the cause, and we are just pushing it to the error queue. So we have a flow reference, and over here just creating a flow. So this just creating a payload. So this payload is similar to what we have seen in the dlq-utility-api in its on error propagate. So app id is the app name, so the name of this app, which is orders api. Message is the payload, and we are serializing the payload, and then it will be converted into binary byte of array in the error api. Cause is retry is exhausted, and description is error description, and so type will create the namespace identifier and the attributes. Now this retry is exhausted is quite misleading over here. This needs to be corrected because even this is using the same thing, right? So instead it should be wars.cause. So let me just update it, wars.cause, so that right, wars.cause. So yeah, so the variable name, I've updated it with the variable name, and then it pushes to the error queue. So we are pushing the message to error queue with the payload that we have, and we need not push any properties or anything because we are already sending it as part of a payload. And then we finally acknowledge the ACK using the attributes ACK ID. So we are using the backup attributes because we do not know where in the flow the mule event gets modified, right? It changes, so we are using it from the variables that we have stored all these values. So that's the overall flow for an API in case of an error. So it makes sense to use this global error handler and import it in other projects as needed. And then we have all these three projects linked to the domain, which is the reliability domain, and it has only two configuration, database and AMQP. So now that we have understood the whole flow of application, how we have designed and developed, now let's try to run all of this application and see it in action. So before we get started with this, we'll just see what queues do we have. We have a dead letter queue, we have error queue, and then we have the orders queue, right? So dead letter queue and error queue do not have any dead letter exchange or dead letter routing key. It's just that the consumers, I mean the application which leverage this will have it. For example, orders queue, it is having dead letter exchange as error x and dead letter key as dlq. So if it gets rejected, it will have this error x and the routing key dlq. So using this routing key, the error exchange will push the message to the dead letter queue. So that's the idea. Alright, so now it's time to validate whatever the framework that we have created. So let's try to run this. So I'll just run the domain, and all the linked apps will also get deployed. So let me run as mule. Let me configure. So I do have a configuration, and I'll tell you what I've done in this configuration. So the idea over here is uh, the database that I have is an Oracle database, so it uses Oracle driver. And the problem most of you might have encountered with Oracle driver is that it returns java.oracle timestamp, but data view understands java.sql timestamp. So when we add this particular property, J2EE13 compliant, the driver is forced to return the java.sql timestamp, which database can coerce it into its own timestamp properties, right? So that's the catch. So I had to add this as the JVM argument. Now let's quickly run this application. Okay, let's ignore these errors and let's see this in action. So while it gets deployed, let's have a look at the database so that we can validate our understanding. So if I go to this SQL workshop, object browser, so while it's loading, alright, so I have dehydration DB. Alright, and let's see the data. So there's no data in this DB. Let's go to the error DB, and there's some data already populated. So if you see, we have my connectivity error occurred. It exhausted all the retries. So similarly, right? So how many? So we have multiple rows. So the latest row will come over here, and we'll just validate it. So first point would be the dehydration DB, where we'll get the message, and then those will be deleted from here, right? So let's see if the application is deployed. So it's getting deployed. Might take a while because we have 3 applications to be deployed. So let's just give it some time. So meanwhile, what we can do is we can send a message. So we'll send it through an exchange. So we have this order queue, and this order queue is bound to an exchange, which is the orders X. So from here we'll send the message. So but let's see if it is started. Alright, I do see there's some connectivity error at the DB end. Alright, I think I need to change the connections. It has got deployed, but I guess it won't work, right? So it's not able to establish connection. Yep. So the connection details are incorrect. So let me just quickly correct it. Let's go to the reliability domain, database config. Alright, so this is not in use anymore. So I'm using this server. So let me just update the host name. So the reason why it got changed is like once this is some remote machine, right? And once it gets disconnected from the network, the DHCP provides a totally new IP, right? It doesn't have any static IP allocated. So every time it connects to the network, it gets new IP. So that's the reason I have to change. Let me just test this connection. And if it's successful, then we should be able to redeploy. Yeah, so connection is successful. Let's click on OK. Let's go to the AMQP config, change this as well. Right, let me remove this protocol. Let's test this once. Alright, so both the connections are successful. Let me save this and try to run it again. Run as mule configure. Use this one. Properties are set. Let's run it again. Okay, the build is success. Now let's see if it gets deployed. So the application has been deployed successfully. Now we do not see any connectivity errors as such. So let's just validate first of all. Let's go to the queues and see if we have consumers or channels established. Okay, so dead letter has channels established. Let's see if error queue has channels. So yep, error queue also has channels established. Okay, then let's go to the orders queue, and order queue also has channels established. So the queue consumers are all well connected, and for DB consumer as well, we did not see any errors. So we can assume that everything is fine. Let's just check the logs. I think the schedulers have kicked in, so it's retrieving records from error DB. No records present in error DB. Okay, yeah, so the scheduler is kicking in and it's able to fetch the records, although the records are not there, but at least it's able to connect to the DB. So we can assume that it's working fine. So now it's time to test the framework. So let's go to the exchange and to the error orders exchange. Let's check the bindings, and it's directly bound to the orders queue. So let's quickly publish a message. So make sure that you pass the content type, because then otherwise it will fail. So because we are not passing it through an application, right? So we are manually pushing. So it's important that we send the content type JSON. Correlation ID, will give some correlation ID. I'll just modify it as 8G1B. Yeah, so these two properties are enough, and now let me send a message. Test message. Alright, now let's publish and see what happens. So I've published the message. Now let's check the logs. Okay, so it quickly did the processing over here. So first let's quickly check the DB, because we have to check it before the scheduler kicks in. So let's refresh. So we see a record, right? And what do we observe? Created timestamp is 1st August. Time is 2:17 p.m., which is 14:17, and that's right. And the expiry time stamp, if we see, is it was 12, and now it is 22. So it's like 10 seconds. So it added 10 seconds. And then we have the payload. We are not able to see it over here, but it has the payload. Then if we go to the headers, we see the dlq retry count added as 1. So we saw, right, we should have only 4 headers. First death exchange, which is orders X, first death reason rejected, and first death queue, which is orders queue, and then we have the dlq retry count. And these are a bunch of properties that we added. So in some moments this message should be removed, but now let's go to the log and see what's happening. So the message came into the orders API, it seems. Yeah, so the moment it came, it threw a connectivity error, my company connectivity. And then what happened over here is like rejecting message for retry, because it was well within the count, right? Count was null, so it took the default as 0, and so it's printing the count as null. Then it comes to the dlq-utility-api. dlq-utility-api is printing everything. Then it's printing the transformation. So the routing key is the queue name, exchange is the orders X, then the MIME type is JSON, properties and headers, and payload is, this is the payload. So it's stringified JSON, and we have converted into binary. So when it goes to the DB, it's in the form of binary large object, which we are unable to see at this point of time. Properties are also serialized, that is stringified JSON, and because we use the write function, and same goes for headers. Then this message was inserted into the dehydration DB, as we see, and data inserted successfully, request completed. Now this is for error DB. The scheduler runs again and again. So then we have the dehydration DB scheduler kicking in. So if we see, it retrieves the record from DB, and then it got publishing messages to the queue. It published the message to the origin queue, and we see it failed again. and it should have increased the retry count. Now let's go back to the dehydration db. So this retry count should be incremented to 2. Just let's validate. Okay, I think it got re-triggered, but we still have the logs with us. So if we check the logs, and if we see here, rejecting message for retry count is 1, right? The count was 1. Then the same thing. Then we have, if we check over here, alright, so these are the original ones, and this is the one that goes to the db, right? So this might have the incremented count, so this is 2, and after this it might have quickly pulled the records again from the db, and we see over here this is what was pulled right from the db, and it pushed to the origin queue. So we have set it to like what, 2, right? So when it goes above 2, it will be automatically rejected. So if we see, it came back connectivity error, and the count was 2, right? Retry is exhausted, moving messages to error queue. So since the count was 2, it just removed the message from the retry, and it is pushing to the error queue. So this goes to the error queue flow, and what we see is the error db message. So if we notice over here, so this is the message that's going to the error db, and to understand this, refer to this is error utility API. So it's an error utility API, right? So system name, so it's coming properly, it's the orders API which has sent the error message. Correlation ID, which we saw. App ID is orders API again. Then error type, it's a namespace and identifier construct. Then the description, connectivity error occurred, created timestamp, cause was retries exhausted, and the retry flag is being sent as n, so we can change it to y if we want to retry it again. So yeah, so that's the values that we have. Now let's quickly go back and check the error db, what we have over there. So if we go to the error db, let me refresh this, go back to the table data, and what was the ID that we used? It was 8D71. So let's copy and check if it's present over here. Alright, so we have this record, right? So it's orders API from where it originated. This is the error, mycompany.connectivity. Description, cause was retries exhausted, so it was pushed at 2:19 p.m. so it's around the same time. So it's 23 right now, but like, yeah, we spent some time in understanding the logs, so it's 2:19. Orders queue was the queue from where it originated, and this is the data type, and we have the MIME type, application JSON, and character set is UTF-8, and these are the bunch of headers that we have. Alright, so this is about whatever. So now what we need to get is, like, we need to understand if the payload is actually making it or not. So we are not able to view the payload right now, correct? So, and yeah, two things I left. So this is properties that we have. So we have all the properties, and the retry flag is set to n. So if we change it to y, it will get retried. So before this, what we will try to do is we'll try to see the payload, which we are not able to view it over here. So let's try to check if we have any way to understand this payload. So to understand or realize the payload that we are sending, it's in blob format, right? So we were not able to see it in the browser mode of the Oracle database. So I've opened SQL Developer, and this allows us to check the blob values as well. So I have selected all values from ErrorDB, and this is the ID 53, and this was the correlation ID, right? So it's orders API, error type is my company connectivity. So now let's quickly check the payload. So if we go to payload column, and this is the one. So if we open this and view it as text, we see the saved message, right? So it's test message. So it's exactly what we have sent in case if the message is there in the queue. Yeah. So this is what we have sent. Exactly the same has been pushed into the database, correct? So application JSON, char set UTF-8, and now you might be wondering how this character set has come when we had only sent content type as application JSON. That's quite fair question. Now the reason why this has occurred is the message went to through two retries, and once all the retries were exhausted, it utilized or it leveraged this flow route, which is global error handler, and it goes through this route and it goes over here. So in this case it's being published through this error queue AMQP connector, correct? So this connector automatically adds the character set along with the MIME type separated by a comma to the content type properties of the queue. So that's the reason our content type application JSON was overridden by this, and it has the character set in it. So that's the reason you're seeing the character set as something like this. Similarly, I have tested it with different values like XML, so it works very pretty well with XML as well. So this is the XML. So in the same manner we can push different messages. So we also have headers and we have properties, so we can also check this headers. Let's just view it once. So it's quite long. So yeah, here's the headers, we have everything, and we also have the properties. Alright, so here are the properties. Now what I want to see is, like, I want to check the retry flow for the error API, right? So what I can do, I want to just change the flag for this particular record as n. So let me just edit it. It's n. Let me make it as y so that it gets retried. So we want to test the retriability of the dead letter queue. Sorry, the error utility API. So let me just retry flag equals y. Let me just apply the changes, and it's y. So in the next schedule it should pick. Okay, it has already picked up the message. So if we check, the state should be changed to I. So it has changed to I, right? And now let's quickly go to the dehydration DB. Select star from dehydration, because it doesn't have the X retry count, right? So we saw it in the code that we removed it. So let's go to the dehydration DB, and we have this message, right? So it again, now it will go through the two retries, and after that we'll have another entry. So this is the blob, and let's see. So the same message has occurred here. Let's see the retry count. So the dlq retry, okay, so it was so quick, it already tried for 2 times. Alright, so after some time it should land now into the error DB. Okay, not yet retried. In some time it should get away with it. Let's see if, okay, so that's connectivity error, which is expected. Okay, I think that dehydration DB is not yet called. The scheduler, I think it runs on longer time range. So let's wait for some time until it pulls the record. So what is the expiry time? So it's 2:33, so the message is already expired. So okay, let's wait for the scheduler to kick in. So let's try it again, and looks like the scheduler kicked in. So I think we should go to the error DB, and I guess there should be a new record. So it's over here. So it didn't change the correlation ID, but we can enhance this to update the correlation ID when it goes for the next time. But it was quite obvious, like we have traceability, so that's the reason we have the same correlation ID, and it doesn't matter because we have a unique ID. So now it's the same thing. It came back here, connectivity error occurred, and create a timestamp 2:34. So it's the same timestamp, it's like a minute ago. So that's fine. If we go to the blob, let's check this. So it's the same message and the same set of properties that we have. So this is the headers, and we do not see any like the dlq retry count in it, so that's as expected. And then we have all the properties. So we see that it's working as per our expectation. It retries the message, and the flag should be n for this, right? So it's in n state. So yeah, so that's as expected. It's in the third row. Let me just check this. Perfect. So it's in end state, and we can, if we change it again to y, it will get retried. So this validates our framework, and it's working as expected. So what do we observe? So in this case, we see that the message is safe. It never gets lost in any condition. It's We are offering a guaranteed delivery that the messages will be delivered, it will be retried, and in worst case, if all the retries fail, it's still safe into the error DB, and from there, with some manual intervention, we can retry. So we are just uh, having a robust mechanism to avoid, I mean, to tolerate any errors, and then we can just retry or retrigger message or whatever we want to do. So now one good thing to see over here is that this dehydration DB is giving us the ability to be reused by some other API, because dehydration DB along with the combination of dlq utility API gives us the ability to pause some of the jobs. So if you want to leverage it, you just need to push the message to the dlq utility API along with like modifying the expiry time. So the expiry time will be inbuilt into it, so it will automatically give you some pause exponentially in the second, third, and fourth time, and then you can do this. You can retry the messages. So two purposes it can fulfill. So that's it for the reliability framework. I hope this video might have given you a good understanding of how to design and develop a framework for reliability. And I hope you might have found this video useful. Thanks for watching.